genericity or generics is a concept that was probably covered in ICS 240, but I will give a little review here in this video. We will be seeing more generic concepts a little later in this course. Generics is a mechanism for creating classes or methods that only vary in their types. So it can be, you can make generic classes, you can make generic interfaces, you can make generic methods. So for example, let's look at this class where we store objects so that we can store just about any type of data in this stack. So we have a node storing data that can be of, that is of type object. And of course, it has the next object in the stack. So when we push onto a stack, you can see that push is a method in stack. We are pushing an object. And when we pop, we get an object back. So this is good in the sense we are able to store any object in this stack. This stack can be instantiated and we can store just about any object. And that is also a drawback in the sense into the same stack, we can store non-homogeneous things like we have an integer pushed into my stack, and then we can also store a string if you want. So we can make mistakes. We push a string here, and then we say, I want to pop and get an integer out of it. We are trying to take a string and then casting it as an integer. Because we pushed a string, we are going to get back that string. And if we make a mistake with the type, we get a crash. So we would like to see if the stack can be created to store only objects of a restricted type. That is where generics come in. So when we declare the class, we don't declare it like this, class stack. Instead, we write class stack, and then in angle brackets, stick in a type, E. And when we write push, we are putting E as the type, not object. So this E will be specified when we instantiate the stack. When we pop, we get E. What is that E going to be? That is left unspecified here. This is the generic. So it is a generic. This is the generic type. And the convention, by the way, in Java is to use single letters capitalized for the type, for the generics. So when we create an instance of stack, we can specify what kind of data we want to store. So we write stack in angle brackets, the type. So this integer is what E is for this declaration. So my int stack would be a stack in which all E's will be essentially integers. So this E will be an integer, this E will be an integer, and they all come because we wrote stack integer in angle brackets. So this E is an integer, and that propagates to all the occurrences of E in this. So we'll only be able to push integers into this. We won't be able to create a string and put into this object. So when we pop, we know that it is going to be an integer. No casting is needed, which is a huge advantage. We don't have to worry about what the return type is going to be. It is going to be integer because this is E, right? And E is integer. So it is a big advantage to writing correct code. It is a big help in writing correct code.